Well, hello there. Good morning. I have just finished my Williamson push-pull amplifier as seen here on the schematic. And I'm probing the amplifier through the frequency range with sine waves and square waves as well. So this is the schematic. Right here you can see it's a dummy box with 8 ohm resistors, non-inductive resistors, okay, for dummy load. And here is my old CRT scope, which works pretty well. This is my gear, which I will be using for probing. I have recorded a CD because I don't have a function generator, well, a good function generator. So I recorded some tracks here, and they sound very well, and you can see here on the scope. These are the frequencies which you can find on this CD, from 10 hertz to 22. But my CD player, despite of having a very good behavior, only works from 20 hertz to 20 kilohertz. So it will do nothing on 10. You can't see any sine wave at all. And at 22, you will see that there's a diminished sine wave, which indicates a less gain, but still a very clean sine wave. And now the amplifier is this one. So it has some 6550 tubes, and driver tubes are the 6S and 7. It's all working properly, and I'm probing. So you can see here the cables, the RCA cables and the speaker cables. So I'm using one channel from the CD player directly, which is this one here. One side from the CD player direct to my scope, and the second channel is for amplifier output. So let's see, what do we get here. So we'll start on track number 2, which is a 20 kilohertz waveform. And let's see here on the scope. Not very easy to see here because of the flicker. Let me try another setting. Not easy. Let's measure. Okay, as you can see here, we have a 1 volt peak to peak input to the amplifier, which is at full volume. So 1 voltage peak to peak, which stands for on its output 2 so 2 1 2 3.3 times 5, you'll get 16.5 volt peak to peak. So this is what we're having input, and this is the output. So let's measure dual channels. So this is input, this is output. Let me try other frequencies. So as seen here, we have 16.5 volts peak to peak. So we will try now 1 kilohertz. This is 1 kilohertz. As you can see here, 1, 2, half volt division, that makes 1 volt input. And we still get 1, 2, 3, and half, 3.3 times 5. We didn't change the voltage division, so we still get 16.5 volts peak to peak. So now I'm going to scroll through. So this is 1 kilohertz, 125, 160, 2, and now I'm gonna jump to 10. Okay. So this is the 22. 22, as you see on the first line, it's input from the CD player, which I can compensate to 1 volt peak to peak. So I'm putting more gain. I'm increasing the CD player output. It has a variable input, as you can see. We still get the same 16.5 volt peak to peak. Okay, so I'm going to show you that the amplifier is at full volume, and this is what we're getting. So I will change the volume here. Let's check on the scope. See, this is the amplifier. Okay, full. Now I'm decreasing. Okay, so full volume. And now for the final test, I have a track which has some sweep from 10 Hertz to 22. So as I said before, 10 Hertz won't work on my CD player output, and 22 kilohertz will have a diminished volume. So here we are. It is running the sweep at 10 Hertz right now. I'm going to change the time division here on the scope, but we won't be able to see anything until it goes to 20 Hertz. It should be starting. Here we go. As you can see, it is distorted because I increased the CD player volume, which I will correct. Okay, so let's check only CD player and put back the 1 volt peak to peak. So it's too much. So let's put it working properly. Here we go. 1 volt peak to peak output from the CD player into the amplifier, which is again at full volume. So we will add now the output from the the dummy load, which is this one, channel 2, right here. And now I'm gonna run the sweep test again, which I believe is track 33, this one here. So this is the 10 Hertz, which we won't be able to see. Okay. As you can see, there's no change on the amplifier's gain through the frequency range. Look, input